Welcome to this lecture. We will be doing a deep dive into the fundamental hardware components that form the backbone of any computer system. Understanding these components is crucial for anyone pursuing a career in engineering or IT. We will also examine each component function, how they interact, and their overall system performance. Overview of the computer hardware. The four main hardware components we are focusing on today are the fundamentals of the computer system. The motherboard acts as the central hub connecting all other components. The CPU, which is the central processing unit, performs calculations and executes instructions. Then we have the memory, which typically is in form of RAM, provides fast temporary storage, and we also have storage devices offer long-term data retention even when the power is off. Understanding how these components interact is key to grasping computer architecture and troubleshooting hardware issues. The motherboard. The motherboard, often called the MOBO or mainboard, is a complex printed circuit board that serves as the central nervous system of a computer. The key features include the CPU socket, where the processor is installed, which is this. This is actually the CPU socket, where you actually mount your processor. Different socket types exist for various models. They have different socket type, which we'll be looking at on the next slide. Then we have the RAM slot, which is actually this. This is actually the RAM slots. So the RAM slots are long, narrow slots which hold the memory modules. So this is actually where it is. This is one of the RAM here. This is actually has two RAM slots. Then we have the expansion slots, which is called PCIe, Peripheral Component Interconnect Express slot, allow for additional components like graphics card or network adapters. These are you can actually connect additional devices like your network card, your graphics card, your sound card to this port. So all these are actually on the motherboard. Then the CPU. The CPU is the primary component responsible for executing instructions and performing calculation. The CPU key points are architecture. Modern CPU use complex architecture, more with multiple cores, allowing for parallel processing. Then we also have the clock speed, which is measured in gigahertz. That indicates how many cycles the CPU can execute per second. So if we have a processor that is running at 2.7 gigahertz, what is trying to tell you that it runs 2 billion 7 million instructions per second. So it takes it that long time in 1 second to execute an instruction. So that's what it talks about. Then we have multiple cores. We have cores, which is part of the processor, which talks about allow for better multitasking and performance in multi-threaded applications. Then we have what they call the cache. This is the high-speed memory built into the CPU for quick data access. Then we have the instruction set. This defines the types of operation the CPU can perform. CPUs from companies like Intel and AMD dominate the market, each with their own product lines and performance characteristics. So you understanding the CPU specifications is crucial for selecting the right processor for specific computing need. So there are actually two types of processor. This is actually the two types. This is a pinned processor and this is actually pinless. So this pin success processor on this board, it has no pin. You just slot it in, it accepts the pin. There are holes on the CPU socket where you just slot the pin and it enters directly. Then you also have this one, the socket has pins over it, so you just place it. There's actually an indicator over here where you just place it and it locks. It just sits on its own on the CPU socket. Then we have the RAM. The random access memory, also known as RAM, is crucial for system performance. Function: RAM stores data and instructions that the CPU needs to access quickly. Is volatile, meaning data is lost when power is cut. So when there is power outage, when your system trips off, whatever that is stored in your RAM is off. Then we have types of RAM. We have DDR, which is double data rate, which is a current standard. So DDR is the current standard of processor, with DDR4 being common. So DDR4 is common, DDR1, 2 and 3. DDR1 is instant, is actually way gone. Then we have DDR1, we have actually DDR2 and 3 actually phasing away rapidly. Then the one that is actually common is DDR4, and DDR5 is actually emerging. Each generation offers increased speed and efficiency. Then we also have the capacity, which is measured in gigahertz. More RAMs allow for more applications to run simultaneously and handle larger data sets. So if you have more RAM based on its size, then capacity, which means you have more applications that can run the same time on the RAM. Speed, measured in megahertz. Faster RAM can transfer data to the CPU more quickly. So we actually have the speed, which determines how fast the RAM transfers data to the CPU. Then we have channels. We have dual channel and quad channels configuration, which can increase the memory bandwidth of the processing. While selecting RAM, consider compatibility with motherboard, required capacity for intended use, and balance with other system components. So my advice as an upcoming computer engineering student, so trying to actually build your own PC, you need to, before you actually, if you are building your own PC, you need to actually consult your motherboard manufacturer. Either you go to their website to look at their documentation or the manual that comes with your motherboard to know the kind of RAM that is acceptable or adapting to yours to the motherboard, so that you can't just go and purchase a RAM that will actually slow down the performance of the motherboard or will not meet up to the performance that the system is actually running on. So storage devices are essential for large term data retention. We have the hard disk drive, usually uses the magnetic blasters to store data, which offer high storage but at lower cost. Then we have they are slower in performance due to its mechanical parts that are actually inside the HDD. So they are actually slow in performance. They are best for bulk storage. So if you are storing large files, we actually advise you go for the HDD drive. Then we have the SSD, which actually uses a flash memory to store data. They are much faster than the HDD, especially when it comes for random access. They are very fast. They are more expensive than per gigabyte and than the HSD, and they are ideal for operating systems and frequently accessed applications. So they are actually very good for apps that you access frequently, and they are very good for that. And also they are actually very fast in processing. Then we have the third one, which is the M2 drives, uses the M form factor in connecting directly to the motherboard. They will use the starter or the NVMe protocol with NVMe in, which is actually this. The NVMe, you can actually, they offer high speed. They offer high speed with superior performance. They are very fast and they are actually ideal for laptops or small form factors and PCs. Like small PCs, they are good for that. And for laptop, they are fastest consumer of storage options. So they are the fastest consumer among all the devices we looked at. The three sitting here, these ones are the fastest, but they actually varies in capacity and their costs are very high. So when choosing a storage device, consider the balance between the speed you are looking for, the capacity, and the cost based on the system intended use. We have the component interaction is actually the key to computer's operation. So data flow, when you open a file, it's loaded from the storage into the RAM for faster access. The CPU then processes the data in the RAM. So when you open from your input device, you load the data from the storage device to the memory takes the data and transfer it to the CPU so it can process the data fast. So then the CPU and the RAM, the CPU constantly reads from and writes to the RAM. So the CPU gets the information that comes from the RAM, the data that comes from the RAM, processes it and either writes it to the RAM or stores it to the RAM. During this operation, the speed of the interaction significantly impacts the system performance. So when this process is going on, especially when you are doing either video editing, graphics, animation, all those high processing or consuming system resources programs, that's where you see the system performance is very high, and you actually have the storage and the RAM. When the RAM is filled, the system may use storage as virtual memory. So you can actually use your hard disk storage as virtual memory. That's why sometimes when you're working on some applications like Photoshop or those Adobe Suite, when you try opening a software to tell you out of memory, but if you go to your RAM has memory. So what it's telling you is that actually your memory is filled up. So it's sometimes it actually switches to your hard disk. It now creates a virtual memory on your storage device for it to be able to process, but it is more slower than the RAM. Then the motherboard rules. The role of the motherboard is for all the data transfer between these components occur through the motherboard. It is just like the traffic warden that directs the communication between each and every of the components. Assign it, okay, this one is trying to communicate to this one, and that's the role of the mother. And its design and quality can affect system stability and performance. Then the bottleneck side, the slowest component often limits overall system performance. For example, a fast CPU and a slow RAM may not reach its full potential. So understanding these interactions help in diagnosing performance issues and making informed upgrade decisions on your devices. So when you are choosing your component, what are the things you need to look at? Selecting the right component is crucial for building an effective and efficient computer system. One, compatibility. Ensure that all components works together. For example, the CPU must be compatible with the motherboard socket and the chipset. So it must be compatible with the motherboard socket and also the chipset. Then if it comes to performance, balance, performance balance, aim for a balanced system. A very powerful CPU paired with a minimal RAM and slow storage will result in suboptimal performance. So you don't just get a powerful CPU and give it a slow RAM and a slow storage device. The system is not going to provide its or deliver its best. So when you are actually considering choosing this component, make sure that you have a powerful CPU that moves with the same clock speed and also the same size, almost a high size in processing power and also a faster storage device so that their performance will be optimized. Then upgrade potentials. Consider future needs. A motherboard with extra RAM slot or M2 connectors offers more upgrade options. So when you're actually building a system, make sure that you get a system that is actually future compatible. In case you want to upgrade, it has the slot, it has the allowance for you to actually upgrade the device. Then use case element, gaming. So if you are gaming, you focus on more powerful system, armable RAM and fast storage for a gaming purpose. Then if you are working for office work, moderate CPU is okay, sufficient RAM, maybe 4 gig, 8 gig, and reliable storage. Then if you are going into content creation, you actually need more processing power. So you need strong CPU, lots of RAM, 16 gig, 32 gig RAM, and very fast, large capacity storage. So, then, but the budget consideration too, when you are doing budget consideration, allocate budget based on priorities. Sometimes it is better to choose a balanced mid-range system, just like the one that is balanced in the middle mid-range system, and budget parts elsewhere. So you can buy a system that is within the budget, then you can actually get the parts from different places. Then power requirement, ensure that the power supply units can handle all the components with some headroom for future upgrade. So whatever power supply unit you are buying, or the power pack as it's called locally, is actually has this feature upgrade. It can carry all the components. Then cooling it, ensure high performance components often require better cooling options. So before considering this, by considering these factors, you can build a system that can meet your current need and also offer flexibility for the future. Then troubleshooting basics. Basic troubleshooting skills are essential for any computer engineer. System would boot. So these are the factors you need to check when your system will not boot. Make sure you check the power connections, ensure that the RAM is properly seated. Try booting with minimal components. Try removing some components, maybe the hard drive, some connections from the system. Just put the system on to know that it comes up first before you start adding other components. Then if you have blue screen errors often indicate hardware or driver issues. When you have blue screen of death, so either there's a driver issue or there's a hardware issues. Then note error codes for research. It's very important. Most times there are different hardware components, there are different gadgets with different manufacturers and different drivers manufacturers. So you can't know everything. Even up till now, I don't know everything. There are some I actually Google, I actually do research. If I see the code, I can just get my smartphone, scan the code, or snap it, browse for the code, error code. What does the code mean? And before you actually get an answer or a response towards that error to resolve it. They also check for recent hardware or software changes. Always make sure that you're able to check for the recent hardware or software changes on the PC. Then when you have slow performance, could be due to insufficient RAM. So if your system is slowing down, check the RAM, maybe the RAM is slow or the hard drive is failing or there's a malware, a virus on the system. Then two, also check resource usage in the task manager. Check the resource usage in the task manager to know what is actually wrong or what is going on. Then thirdly, you can run this check and malware scan, antivirus scan, which is a big defender. Is actually the one that comes, Windows Defender. It's actually one of the best that comes with Windows. You can run that to check for your to scan your system for virus. Then basic troubleshooting approach. Identify the problem clearly. So make sure that you identify what is the problem first. Then when you are done identify the problem, you check that all the physical connections are connected. So every connection that needs to communicate with the motherboard, with the case of the laptop, the desk, the computer, whichever one, let all of them be physically connected well and connected properly. Then test components individually if possible. So you can test the hard drive individually. If it vibrates, you know, okay, the hard drive is working. You test the RAM. If there's no beep, and you know that okay, the RAM is working. So you can test them individually before you now start coupling them. And then update drivers and bio or UFI firmware. So either update the drivers of the computer frequently. Then also make sure that you update BIOS or UFI firmware. Then check for overheating issues. Sometimes the system may be overheated. When system use it after some hours or some minutes, it strips up by itself. Then you have to allow it for some time before after some time it will come up by itself. And that is actually a sign of overheating. Then run diagnostics tools. So you can use diagnostics tools. There are a lot of them online which you can use to diagnose your PC. There are some that are event viewer that's actually on the PC. There are some like this check. There are a lot of these are actually Microsoft. There are a lot of other diagnostic tools you can use actually to run or troubleshoot. Then remember that systematic approach and patience are key to troubleshooting. So document all your steps. Oh, this is what I did. Have them documented and result to help in future issues or when seeking additional help. Sometimes I document my issues. So when I'm having this kind of similar issues, okay, this is the step I take. I'll have to take that step. And most times often, the step you took in resolving one issue also helps in solving the next issue you're having on whichever computing device. As we conclude this lesson on essential computer hardware components, let's recap the key points. So the motherboard is actually the central hub that connects all components. Then you have the CPU, which is the brain of the computer that processes data and executes instructions. Then we actually have the RAM, who provides fast temporary data storage for active processes. Then we have the storage devices for long-term data retention with varying speeds and capacity. So understanding components interaction is crucial for building and troubleshooting systems. So next steps, we actually practice identifying the components in real systems or online resources. So you can actually try gaining hands-on experience by getting a PC or a laptop, open the components, try identifying what are those components on a real system or using an online resources to identify okay which one is the RAM. Then also make sure that you research your current market offering for each component type. Since there is technology is evolving, so there are new trends. So make sure that you reflect or research on new market offering for each component to be sure for the type you are getting. Then consider how different components might be prioritized for various use cases. So thank you and see you when we'll be taking our next lesson on input and output devices and peripheral. Thank you.